Now, I want to give a very special welcome to this man right here. We met, I don't know, maybe a month ago, and he has really been helpful in terms of turning Qdrant into a product that is really enterprise ready. What TrustGraph does basically is allow you to take, for example, that app that I built with Qdrant and inject it with the capability to scale, enterprise ready, security, all of that good stuff. So, without any further ado, break a leg.
I hope not. Well, I feel bad because, you talked about TrustGraph and Qdrant, and my talk is in a completely different direction.
It's okay, they'll get it later.
I hope so.
Yeah.
This is in a different direction, and this is kind of the, I've had friends of mine sometimes say like, you're trying to do too many TED Talks. So, also, am I getting this? Is it because of these? No, there's just a lot of feedback. Okay, I'll get used to it. No, I'm getting this like crazy delay. So, a brief history of trust. What do we mean by trust? Why am I the person to be telling you about that? Well, I have a unique experience. By the way, I hate podiums, so I'm probably going to be walking around a lot. I have a little bit of a unique background. I started working in the DoD aerospace industry when I was 19 years old. It wasn't until recently a good friend of mine kind of said, you do realize you grew up, like literally grew up in a very different engineering culture that's kind of not common anymore. And I literally said, I know, I never thought about that. So I worked in an environment where consequences were really, really severe. Loss of life, severe loss of life, geopolitical instigation, and large-scale societal harms if people make the right decisions. I used to go to work every day thinking that decisions I make could impact people who I know by name's lives. And that gives it a little bit of a different perspective. Also, that all kind of led me out here to the autonomous vehicle industry, where I was actually trying to put all this stuff cohesively together with my background in safety engineering, systems engineering, cybersecurity. How do we manage all of this autonomous vehicles? Unfortunately, it didn't go very well for the AV industry. But what's unique about aerospace? If you go back to its history, it went through these all teething problems as well. Up through the 50s, 60s, and 70s, air travel was still pretty risky. But they figured it out, they fixed it. And what did they do? A lot of it was around creating these blameless cultures where collaboration, even amongst competitors. So all the aerospace companies were collaborating together on these sorts of topics. And really important too is a culture in which when things go wrong, you really do a deep dive into understanding it. And again, going back to blameless, people aren't afraid of these deep dives because it's a blameless culture. Like I said, as we've seen with Cruise, things didn't go well in that regard. Waymo seems to be doing a little bit better in that regard, but they're also much more risk averse. But I can't talk about the aerospace industry without talking about the fact that Boeing hasn't been doing too well with this lately themselves. So you can lose that culture. Matter of fact, if you talk to people at Boeing and the struggles that they've had in recent years, a lot of people will point to loss of culture. And that's another topic which I can talk about a lot, but very different. A lot of things change there. And you think, what is this about AI evals? What are you talking about? Well, again, I see a lot of parallels. I see the types of harms that can come from AI. Whether it's intentional or not, we're talking about societal scale harms that I can only see comparisons really to the aerospace industry. Maybe biochemical as well, but that one has its own processes. And it's not really a good analogy from a technological perspective. And I see just so many parallels. I mean, without going into, I'm sure everybody can imagine when I say this, if we think about history, even recent history, there have been times where things in the aerospace world, commercial aviation, space, etc., they literally changed the course of history. So the impacts to society at large are unfathomable. So I'm going to talk a little bit about process. And if anybody's ever seen this, so just out of curiosity, has anybody ever seen this before? Do you know what this is? So this is what my friend was trying to explain to me. It's like, people literally have no idea what I'm talking about when I say this stuff. So this is what an industry like the aerospace industry lives and dies by. It's called the system engineering V. Now, even if we were in the aerospace industry right now, most people in the room would go, that. Yes, it's very process driven. Yes, it's very onerous. Yes, this means mountains of paperwork as you go through both sides of the V and how they connect across the V. But is there anything we can actually take from the systems engineering V that might be useful? And this is a concept I've only really seen this nuance in the aerospace industry, and that's the difference between verification and validation. Most people go, isn't that the same thing? Not exactly, and it's an important difference. So verification would be, say you have a list of features that you want to, that you're tasked with developing, and you develop those features. When you did that, you built them. But does it achieve the outcome you want? This happens a lot of times with airplanes. You design this jet and you want it to, and you want to fly Mach 2.7. You want it to fly about 80,000 feet. Those are measurable things. But then you go, does it actually accomplish the types of missions we want to accomplish? And that falls into this bucket. And that nuance is really important for incredibly complex systems. Can we learn anything from safety engineering? Which is another domain that I realize is very institutional. As in, if you worked for a company that cared about that sort of stuff, you probably got trained on how to do safety engineering. Otherwise, I don't know any academic programs that are ever going to teach you how to do safety engineering. So things like hazard analysis, fault tree analysis, FAMICAs. I've mentioned that lately. FAMICAs and FAMICAs, and people go, huh? What is that? Well, hazard analysis is not even what people think it is either, because a hazard is actually a source, mechanism, and an outcome. Fault tree analysis, I think people kind of understand. It's where you put a tree together of events and calculate the probabilities. There's ands and there's ors, etc. Now, FAMICAs, that's one that people aren't as familiar with. That's where you calculate the failure modes, their effects, and the criticality of the system. So all the hazards that can happen, but then how is the system itself linked? And all of these things come together to actually how you analyze and assess risk, and then make decisions. Now this sounds complicated, and it is, but in the physical world, where we were doing systems engineering, where we're doing safety engineering, even for something like an airplane, if you get a team of people and you put them in a room for a week, they will be able to come up with all the permutations and all the situations. By the end of the week, we did a good job. I think we got at least 90% of them. Now, there is one domain where that has not held true, where people go into rooms for a week to try to calculate all these permutations and situations, and at the end of the week, the survivors, if you either survive the battle, the Lord of the Flies, feel like they haven't accomplished anything at all. What industry is that? Information, cyber. If anybody in here has ever dealt with cybersecurity threat modeling or risk scenarios, you realize how quickly this spirals into the what-if game, where it's just endless. What if we do this? What happens? What if? What if? What if? What if? What if? It just never ends. Even with, though, good processes, do humans make good decisions? Well, I got bad news for you, we don't. And this is not an opinion, it's fact. It's been proven time and time again by many a Nobel Prize winning behavioral economist. People like the recently passed Daniel Kahneman. Matter of fact, this is like a little cheat sheet from his very famous book, Thinking Fast and Slow. One of the things I do find fascinating is that, so by the way, you probably heard people in AI talk about System 1 and System 2 thinking. Well, this is where it comes from. But that's not all that this book was about. Matter of fact, that's not even what it was majorly about. It was really about all the cognitive flaws in human decision making. And this is just like a cheat sheet on the big ones. And there's lots of them here. And these have been proven time and time and time again through peer-reviewed research, through double-blind studies. This is humanity right here. It's true. It's all true. What's also interesting, though, I look at this and I realize this is kind of like failure modes for human cognition, which I find interesting. So, we have this unmanageable problem, information, that we don't know what to do with. So how have people tried to do it? How have people tried to make information risk decisions? Well, they do the high, medium, low, the heat maps. You've probably seen that. And most people aren't really satisfied with that, so they try to invent new ones. One that got invented a while back was actually giving grades, like A, B, C, D, F. And a lot of people thought, wow, that's great. But there's a fundamental flaw with that perspective. Anybody got any idea, from a business perspective, what's bad with assigning grades to risk? Anybody? Yes, what is it, Art?
What if like there's a C problem, but it's actually an F problem?
Well, that's kind of getting at it. So, say you're an executive and you're focusing on like what things do we focus on? And was that somebody? I thought something. So you're focused on making money. You're a business. So your risk team goes, well, these are all, this is the work we do to get us to an A. And the executives go, how much work do we do to get to a C? And the risk people are like, ooh, why would you want to do that? But that's not good. That's a C. And the executive goes, but that's a passing grade. But it's a C. Well, I don't care. I want a passing grade. I want to spend as little money on this time as possible. So giving grades didn't really stick around. I mean, I think some people are still doing it. Don't recommend it. A good friend of mine, Jack Jones, the creator of FAIR, he's dedicated most of his later career to this problem. And he developed a methodology of loss exceedance curves. Mathematically very sound. Does anybody see a problem with this though? And I can say this because Jack knows we talked about this stuff. Anybody see any problem with this? Well, I see a lot of people staring at it right now, which that's the problem. This isn't really intuitive. Like, you need a lot of education to just understand what this means. And even when you do understand what it means, it's not super intuitive how you make decisions with it. The best critique I ever saw of FAIR was on Reddit, of all places. Somebody said, we instituted a FAIR program, we did the analysis, and it turns out we made the same exact decisions we made when we were using a much less granular methodology. This is people that do cyber risk. This is their lives. Because there's not a good way to model these harms. What happens? You end up with an industry that's reactive. What does that mean? Instead of proactively making decisions and doing work to mitigate risk and harms, they wait until something bad happens, then all of a sudden, oh yeah, you're right, we need to do something about this. So what do they focus on? Bare minimum compliance. What is the bare minimum they have to do? We have this compliance requirement, let's just do the absolute minimum and be done with it. And then also, how do you actually model what you did was worth the effort? If you have a team that you want to spend 2 months doing this? Are we getting a positive ROI on it? How do you model it? And as if you've worked in the cyber industry before, you know that how you sell in cyber is with fear. You fear monger. Bad things are going to happen. You're not protected. It's the only way to sell cyber products. I hate to say it, but it's true. I promise it does. It does. Let's look at an example. I found this one recently. And yes, you can ask me off camera where I found this. This was actually published by somebody we really well know. Nobody here about it. I was looking at a project and they had some evals built into it. And I looked, I'm curious how they're doing that. And they're using an LLM to do the scoring. I'm like, okay, so how are they doing? These are the 3 examples they were giving the LLM on how to do the scoring. So we have a true answer and a model output. And we're doing a score from 0 to 1. And so the first example, the sky is blue, that's a 1. Okay. Example 2, the color of Alexandria is blue, the color of Alexandria is green, 0. Okay. Example 3, let's look at this one. Let's really look at this one. We're to really look at it. So, this is the true answer. The color of Alexandria is to discover and organize knowledge into a structured form. And the model output they proposed is the purpose of Alexandria is to extract knowledge. Okay. Let's break this down from a linguistics perspective. Does anybody remember diagramming sentences? You and me, it's just us. I've said this to other people and they're like, what are you talking about? Do they even teach it anymore? Maybe they don't. So if you learn how to diagram sentences, you break down sentences into their actual structures. And if we do that for this, the subject of this sentence is color. Alexandria has nothing to do with it. The subject is color. Color is, and the predicate is, to discover and organize knowledge. That's what this sentence breaks down to. So how does this map? So in this situation, the subjects don't map. Does purpose have any definitions that match color? Not even close. So if you go to a common dictionary, color has about 20 different definitions. 2 of those are not about appearance, those all have something to do with appearance. There's 2 that are slightly different, but do they actually map to the word purpose's definitions? No. Is purpose a synonym of color? No. So let's think about this. The subjects of the 2 sentences are very dissimilar. The way the English language, and again this only applies to English, the English language, this means this statement, this sentence, is focused on the subject. The entire purpose of this sentence is to provide us information about the subject. So, what we think is a fair score when the subjects don't match. Now, I can make an argument, it should be a 0. The subjects don't match. I mean, you can also make an argument that some of the definitions of the word color could maybe overlap a little bit with purpose. The predicates are obviously very similar, I'll agree with that. But from an accuracy and precision perspective, what can we really score this statement? Like, based on everything I just said, what's some suggestions? How would people here score this? Anybody? I'm going to show you what they actually scored it. But I just want to get some ideas. I want to see if people agree with their score. Well, don't worry, it's not going to be what you think. To these developers, it's a 0.9. I have a theory on what they're thinking. A theory? But from a linguistics perspective, I don't see how they're getting to this, which worries me. And here's why. I think if you read the paper behind this repo and this tech, they did a lot of training on synthetic data. So a lot of their evals are based on, we fed in this synthetic data and we want to see if the model can reproduce it. There's a problem with that though, because the synthetic data basically creates new definitions for words and new context. So what's really happening here in this situation is, are we trying to conflate the words color and purpose? They naturally don't have those definitions. Are we creating new definitions through this process with the synthetic data? And if we are, what are the implications when we try to understand language? Will we be using the accepted definitions? I don't have answers to that. I don't know that anybody in the space does. I think this is a big concern. Again, I'm not trying to be critical in this talk. Again, that's why I started off this talk about my background. I come from a culture that's about solving problems. And to solve problems, we have to accept we have problems. These are challenges. We can't sweep them on the rug. We can't pretend they don't exist. These are real challenges that can lead to real harms. And there's more to that too. We're just talking about an individual sentence. So what if we talk about a paragraph? Well, yeah, grammatical structure. I didn't even talk about that. You can have a sentence, and you can have the same sentence with the same subject, verb, and predicate, but it can be structured in a wildly different way. You can have dependent clauses, you can have infinitives, you can have gerunds. You can have so many ways of structuring the same idea in a different package. Are these models going to score it the same way? If you have a paragraph, what are the chances that all the sentences are going to be exactly the same order? And then the longer it gets, we know that models struggle to miss things. There's a lot of things that are going on in human communication that give us clues as to how to understand these ideas. And here's an example, here's a little exercise. So let's imagine two situations. So on the right, we have where a random stranger just walks you to you on the street and says, tell me your social security number. You don't know this person, stranger. How are you going to react? Like, why would I tell you that? Who are you? We're just standing on the street. This situation is a stranger, once again, a random one, you don't know who it is, at a call center. And he says, tell me your social security number. But what do you do in this situation? Let's say this is the phone number for your bank customer support, and you're trying to figure out why there's a charge on your credit card you don't recognize. Well, in this situation, you're going to go, I'm not going to tell you. In this situation, you're not going to think twice. You're going to tell the stranger your social security number. So the same statement, tell me your social security number, you interpreted and responded to in a wildly different way because of things like situational context and individual context. And the reason why I talk about verification and validation is something that we as humans do to respond to language in every situation. We're verifying and validating intent. Because we couldn't understand why a stranger on the street would want to know your social security number, you're like, nope. But the random stranger at a call center, well, you're talking to that person because they're trying to help you. So you're going to volunteer that information. But if you look at that language, that statement on a sheet of paper, it's the same thing. So why would you respond to it totally differently? And we're doing this every moment of our lives, calculating how we should respond to these requests. So how do we establish trust? At the individual level, we have methods for establishing expertise. You get a degree, a college degree. Maybe you get a master's degree, you get a PhD. Then there's lots of professional domains where you can get certifications. And then you get to a point where you have 20 plus years experience in a topic. Well, that establishes your expertise. So we trust you. What do we do for rare events? Like, driving a car. Driving, you have so many permutations of what could go wrong. Insurance. And what do we do in the B2B world? Best practices compliance. So we establish these standards, frameworks, guides. We show that we followed these best practices. And you go, well, I trust that you did everything that you could. So where are we on the AI? Where are we with AI on all these? I mean, we got some of this. We have people that have degrees in these topics. Certification, experience, sure. Insurance? Do we know how to insure an AI system? Best practices. What are best practices for AI and agentic systems? I can tell you this, my experience, because I've gone through this in DoD, I've gone through it in the AV industry, it takes years to come up and develop best practices. It takes years to come up with standards. You have to work with public-private partnerships, and then you have to do a lot of political wrangling to get support in government for it, and then you have to get support amongst your competitors to adopt it as well. It takes years. And I would say we're not at zero on this one, but not far from it. You're probably thinking, well, you come from aerospace, you're going to argue for lots and lots of process. Not lots and lots of process. It's a balance. We're over here right now. We don't have a lot of process. So when we get chaotic action, well, we get lots of action, and sometimes that's construed as a good thing. We're getting lots of action, but it is chaotic. And I think everybody would agree that the agent space, AI, is very chaotic right now. People don't agree on what's the right approach. We have people investing lots of money in approaches that are very different from the next investment. And we also see this side, the lots of process and chaotic inaction. We see that playing out in our government. This is why our government's in the news so much lately, is because people feel like we got to this point of chaotic inaction. And I can tell you, having lived it, that when there's so much process, nobody knows how to actually accomplish the process. People find ways to get around the process. So that's why I call it chaotic. It's a different kind of chaotic. This balance in the middle, very hard to achieve. And what are we even trying to balance? Harm can take on a lot of forms too. I think that term, I use the word harm because that is the correct legal term. And I think that's important. Harm can mean any type of injury, loss. It can be physical harm, it can be mental harm for a business, it can be financial harm, it can be even, you waste the company's time, that's harm. It takes on many, 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 many forms. For instance, if your AI, if your agent gives somebody bad information in a company and they go off and execute something and it ends up not working out, you call it harm. Now, whether or not you're going to get sued for that, maybe not, but still, they can argue that you injured them, you caused harm to them. The balance that comes between risk and opportunity, this is where the fulcrum really lies. There are risks, there's also opportunity though. And we need to be able to understand these two to make good decisions. But again, how are we even doing that right now? How are we doing it right now? And why is this so important for agentic systems? I had a conversation with some of the folks at Anthropic just last week, and it's because once you have these huge amount of agents working together, this thing all of a sudden becomes like a black box. What's going on inside of it? I don't know. You have so much automation, so much work being done where A language model is now the switching mechanism, making decisions on what task to accomplish next. You can end up with this chain of events that you go, how do we know how we got there? Here's an example. Say you have an agent system that's designed to do drug discovery. So let's think about what kind of things you would need. You would need to be able to research chemistry, physics, human physiology, biology, effects on people, actual process of, chemical process. Well, guess what? That's the same exact way you design an agent that was going to design a biochemical weapon to do harm. It'd be the same exact processes, the same exact knowledge bases. So how do you know when somebody's actually trying to develop a drug for, curing cancer versus somebody's trying to design a weapon to do harm? When it's using the same exact knowledge bases and the same exact processes. And the moral of this story is, and this is based on my years of experience, and considering that I'm only one of 1 or 2 people that knows how to diagram a sentence or knows the systems engineering B, I think you will all agree that I'm old. That should satisfy the experience part of expertise. It's very easy to overcomplicate this. The cyber industry's done that, which is why the cyber industry still struggles on how to make decisions. And I don't want the AI industry to do the same thing. We can really, really easily overcomplicate things. We need to focus on avoiding harm. Now, how do we do that? A lot of people talk about guardrails. But do we think we can design guardrails for every single possible situation that might happen? It's almost an infinite number of permutations. Do we think we can capture them all and have them declaratively defined as we have a guardrail for every single one of these situations? The cyber industry doesn't even do that. No, what does the cyber industry do? So does anybody know, in the cyber industry, do you focus on building defenses or what do you focus on? You focus on detection and response. And I'll give you a good analogy. Think about your house and what you focus on to keep you and your family safe. You could build lots of defenses. You could have a door. You can add lots of locks to that door. You can add bars over the windows. You can build a fence. You can build a bigger fence. You can build a moat. You can build so many defenses. But do you? What do you actually invest in? You probably invested in a bunch of cameras that are connected to your phone that immediately alerts you when something picks up something on the camera. We know that the investment goes into detection and response. The faster we can detect something's gone wrong, and the faster that we can respond to it. This is the only pragmatic way we can begin to even potentially solve this problem. Now, since I'm up here, I might as well talk about what I do. On that cheery note. TrustGraph, as Thierry said, is a full agentic solution stack. It is also open source. Our preferred vector database is Qdrant. We have multiple different kinds of RAG pipelines, vector RAG. We also have graph RAG. We support many different kinds of knowledge graphs. The graph building is automated. You point TrustGraph at your data, it will build the graphs for you, and it has all of the features needed for true enterprise-grade scalability and reliability. And why do we put trust in the name? Because this is something that's really important to us. Some of the things that are on our roadmap coming out very soon are things like how we're using knowledge graphs and vector embeddings to actually create role-based knowledge controls, so that users will be prevented from getting information about particular knowledge sets down to the topic level. Also, because we have that full stack, we can actually do real-time detection of unwanted incidents. And because we can do that feedback loop, we can start to establish patterns of use, so we can begin to understand human intent.